So although it's still 2 minutes before we start, but probably we can talk some arrangement a little bit because I already announced, but I just repeat a little bit. It's about the venue. I mean, I noticed that some of you don't like to bring their laptop, and I try to schedule the B.A. lab, which is the computer lab in the B school, and turn out that it is highly competitive. It's very difficult to get. For our class, we're only able to get one, which is I think it's the October 9th. It's only class we stay here. But for the other section, we're able to get for maybe able to get more because we are not allowed to. We only can book month by month. So possibly the other class will be on the lab. So if you really hate bringing your laptop, in that case, then you may consider going there. But of course, there's a seat limit for that room. So if everyone go there, there's an issue. But I guess if you're happy on Wednesday, then you can still come. You should bring your laptop to the class. But I mean, if you don't bring, it's okay. It's not a big deal because I think this class has record or the code is there, so you can just always go back, take a look. But if you really want to work together, I can help you, then it'll be easy, right? Of course, we have TA, then always you can refer to her when you have problems. But I think that you've at least a Python probably is good to do it on spot. So I think the time is you can take a look. If we're able to get more lab room, then we'll let you know. But for the moment, I mean, only one class. Otherwise, we're still in this nice part of the campus where you can see outside, can see the nice river. But otherwise, we can see a nice subway. So let's continue where we stopped. We almost done the first set of slides, but just remaining some programming part on the football. But before we do that, I mean, it's after a week and after a typhoon holiday, then many of you may have already forget what we've covered, and especially first class, first week, and also you may be swamped by the driver exercise. So be good to just briefly review what we have done. So we have some idea that when we continue our journey today, so very quickly we will finish the lesson 1 and then go to lesson 2. And one main thing is I want to ask later, probably you can tell me, you reply is it okay we shorten our break for 5 minutes and then you can go to take the bus earlier, because usually this is what some people email me saying that, I mean, if I let you out in 5:15, then getting a bus can be difficult. So maybe I can say shorten the break by 5 minutes, then you can go a little bit earlier. In any case, I mean, let me know in the you reply if you want. I mean, the class time is the same, just cut the break 5 minutes shorter for the both break or either. Let me know. I mean, but very minor. So just let's go a quick review of what we have done. For lesson 1, we basically talk about original data and how to prepare for data analysis. And today, lesson 2 talk about how to do preliminary analysis, basically preparing data, clean it up, and see what it looks like, right? And the main thing about is the original data is where you get the data, right? And then how to collect them and how to assess quality. And this is the set of the command that you should know how to do. Oh, sorry, I should speak slower. So the origin of data, and where we do is how we store the data, and the way we describe is according to Python, which is data table, or they call it tidy table, right? And tidy table can be convenient stored in a CSV file format, which every line is a one observation, and every column will be separated by comma. So it's a comma delimit. And there are different type of data. These days, most common is called the panel data, and that's just what usually you have. Especially for IT manager, you have this kind of data, right? You have each individual, you have different columns over time. So this is the most standard thing. And The example we have, which we'll go again today, is about the hotel data, right? This data set comes from a price comparison website. I think it's price.com, hotel.com, whatever. That is the data. And then we look at these problems and then see how we can import the data. If you use CodeLab, then you will use the CodeLab function, do the I/O thing, and then use the Panda, right? The Panda, if you look at the idea, Panda is called panel data analysis. So that's why the Panda actually will be very useful for our purpose. Okay, and then the main thing is the read underscore CSV is the main function we use is to read the CSV file. Of course, there are many functions you can read CSV file, but the Panda turned out to be very useful because it will import as a data frame or the format that Python understand how to analyze data. Okay, so that is the idea why we use the Panda CSV file, even if not panel data. And the next thing is how to select column, which is the function we call filter. Right, filter is the one that we just the many possible columns. Filter is just to cut out the thing that what we need. Okay, and then we want to take a look at the data. It's called the head. Okay, so I hope that this reminds you a little bit. And although we usually given data, but in general you have to clean up the data, right? But we will talk about something today. But we'll clean up something. Then if you don't clean out the data, then that will be a problem, right? Just imagine you are preparing a dish, right? You try to cook something, right? And you have to say the meat, right? You have to cut out the skin, right? Or the fish, you cut out the scale, right? Or you eat the fish, you don't eat with the bone, right? You clean out the bone, otherwise your problem, right? Same idea. You've done analysis, you have to clean in a way that it can be ready to eat, right? So that is otherwise it's garbage in, garbage out, right? And the important part is how to look at your data. There's in the textbook, they tell you 6 dimensions of the data, right? And then you can assess the data, how good they are, okay? Before you go ahead and say, oh, I got this data, why don't I just do it, right? If they're not good, then garbage in, garbage out, okay? And the other project is the billion price data, right? It's just a lot of data set, that a lot of prices data, then but you can assess how good they are. For detail, you should check the textbook because they tell you very detail how they evaluate. And similarly, there's another data set, it's called management quality, which you're also able to look at how the book describe that how good they are, but you can pretty much guess what can go wrong. Okay. And next, come to define what's big data. And as I said, there's no particular definition of big data, and the book attempt to say it has a property of 4V, but of course you could look at a textbook, they have other definition, but this is a good one. And of course, you're IT manager, probably you would have idea of what big data is, because usually the data you handle is big data for sure. But of course, big data doesn't mean many of the columns are useless. And here we prepare the data. So first thing is when you got data, first understand what type of data is, right? You understand whether the number there, maybe there, the text there, maybe the character there, but understand how to use it, right? Because you understand definition, especially, I don't think you would confuse whether it's a character or the text data or the graphic data. But when you give a number, you understand what the number it is, right? Whether there's nominal, there's ordinal, there's an interval or ratio. Very, very easy to confuse because sometimes, say, gender, they will have 0 or 1. Then you would try to think you can do average, you can do add, you can do a lot of operation. But 1, 2, 3, 4, 5 or anything would just mean number, right? Or your given number for, say, location is maybe the zip code, maybe the location that each province give a number, right? This number just a name, a shortcut, not really a number, representing some province. right? If you try to add and subtract and average, it means nothing, right? So same for ordinal data, right? That's represent order, right? If you try to do some operation, multiplication, especially, these are useless, right? And interval and ratio, I mean, they also have some meaning there, but we don't go to any detail on those, and we assume most likely the data you handle is a ratio data. Start from 0, have some meaning, go up, and you can go down by negative, but that is standard thing, right? So here is data wrangling means that you would try to understand the data, clean it up, and then we do analysis, okay, very quickly. But this is the idea, right? Look at what the missing value, we move the duplicate and look at all these things, understand how different table together and link up together, right? Because that is your raw data, right? Maybe come from different table. You have to clean it up and combine a single table. And once a single table, you have to check whether that all the numbers are making sense. Okay, so that would be the process. And as we said, when we use the Python Panda package, they would expect you to be data in the what called the tidy format. Tidy format because of panel data, so which means that we have each observation from a row, okay, each row, and each column will tells you what the feature of that observation is. Okay, and because of time, that means that if the same observation, right, across time can be on different column, or can be each observation can represent different individual at different time. Okay, so depend on the format, is a Y format or long format, right? Probably used if you still recall, right? In this particular case, right, the hotel, each hotel ID, the price and distances. Each observation would have the price and distance. Okay, installed in this way. Okay, and I think we have done that. I'm not going to repeat, but one thing that would be useful, right, is look at the value count, look at simple tallying, right, and see whether they make sense. And this is filtering, not the column, but the row, right? By this is AOC, just filtering, but this is pick up the accommodation type as hotel, right? Remember, the filter is the horizontal, you filter the vertical one. If the dot arrow C just picking all the type that equal to hotel, okay? We will see this again today, but this is the very standard thing. And this is just to look at pretty particular column, right? So these are the operation that you will need to see what we want, okay? And as I said, just said there are two type of format that the data will exist. And this is the world band data, and then you try to download the data as a long format, okay? By long format means that for each observation, right, the ID will be country and year, right? This is the Y format, okay? Why this Y format is good? Because this is good for data storage and adding data, right? Because every year, if you want to add this thing, just add one more row, right? In the long format. The Y format, later you will see we add another column. That is very costly to do. In terms of, I mean, you guys are IT better than I do. This operation is easier than you add another column, right? Independent, right? Because add column, you have every column, right? So you have to move everything in the database, right? But if you do it at a row, then you just add append, right? They're much easier, right? I mean, you guys are expert, so I'm not going to pretend I'm expert on operation of computer instruction, but you will know, right? In the Y, right, it will be like this, right? Each row is each country, but you have each year observation here, right? Imagine you add something, you add one here, right? That is very costly operation because you have to touch the whole database, right? If append, then it would be much easier, right? Because the operation is much faster. So, and it's easier to handle missing variable, right? Because when you're missing, suppose this guy is missing, then you have to have a missing thing. You still have to record that. But for a long thing, you're missing, then just don't enter it into the system. Much easier, right? So that's why when your database, you always have a long format. But when you really want to analyze, then usually you will see the Y format. Okay, Y format is convenient to do regression. Okay. So here is the data, and then we tell you how to uh, unstack. You can see there's some slight changes to this slide uh, because I divide them into two separate operation, but the same thing. There's nothing changed in the slide. Hi, that's okay. I mean, like me last time. I mean, take 20 minutes, and I promise you I come earlier because I come here 2 hours earlier. Okay, to the NA. I just eat lunch there and then just stay around, walk around, wandering until times come. So make sure that I'm on time. Uh, so and this operation that you would change to from a long format to Y format. Okay, so this operation you probably may worry about whether you would be worrying, but doesn't really matter because it's always this is the country name and year, and then they unset the year. So nothing to do. This is the same operation, right? So the only thing you worry about is to figure out what is this, what's this, what's this, and that's it. Okay. And here is talking about if you have different data, how you combine, right? I mean, if you learn how to combine data that will require a key, right? That is shared among different data, right? You have different table, how do you link to each other is requiring the ID, right? You have to connect different table to be connected by identification thing. So later we say example, but the example, right? Probably we just stop somewhere in the middle in the football thing. We can go back again, right? So this is a table where you have three data set, right? From this website, they call this website, right? And then they use the Python to scrap the data from there, right? And then come up with three table, and then you can download that. I mean, this is a publisher website, and then you can download the data, right? And then we look at this last time, right? This is one type of data set, right? That focus on games, right? So that's why the ID in this is the date, home team and away team, three column together to identify a single observation, right? ID means each observation have own ID, right? So this is a unique identify this game, all right? And here we tell you how to sort it, right? Last time we covered that, right? This ID state, home team and away team, right? And the other one is the teams level, which they have, but they tell you what the long format is. In this long format, like this, the ID is just the date and the team. The opponent team is not part of the ID, right? That means that you should be able to see the first column and the fourth column actually are the exactly same entry, right? They just depend on who you're looking at. So you have to be extra careful when you have data like this, right? Because you duplicate, which means that you would have to worry about how you map the data set. Okay, of course, the book actually jump. Okay, there's a data there, and they clean it up, join it here. Something here middle is missing. Okay, just like when you look at the video, like 1,000 later, and then suddenly end, right? Or you go to, I don't know whether you watch any cooking video. Okay, some people they cook, and then said, okay, because of time, okay, this done, right? Just like this. Or look at the math proof. Okay, proof, okay, it's so long that we skip, go to the answer at the end. So the same as here, right? So they don't tell you how to combine. Okay, but anyway, they combine in some way. Okay, those are team game, and combine. They don't tell you how to. And the other data set is the manager data set is like this, right? And depend on which manager, from when, start when, end, which club, right? So they don't actually tell you how he matched the manager data to games data, right? But of course, he matched through the team, right? But they don't really tell you how to match. Instead, okay, they tell you this is the matching, but okay, whatever, the match result is here. Okay, we don't want, since the book don't want to deal with that, we don't deal with that. But probably he thinks this is a programming problem. So where's that class? So okay, we just leave it for you. I mean, you just figure out how to deal with that. This is the final answer. Okay. But I think, I mean, you guys are expert in IT. That would not be difficult because it's combinative data set, right? Just involving writing some function. You know how to do that. I mean, it's not something very terribly difficult. Uh, I mean, it's easier than the Java exercise that you've been doing. But anyway, suppose that this data, which we care, and we want to look at the top managers. Okay, so let's continue this code again. Let's, if you still have the Python with you, will be here. Okay, if you don't have the Python code, we can go to the Blackboard, which is already the code is already there. Then you can open that one and copy one to your own system. Okay, if you forget, you can go here, and there's a code lab link. You can click on this one, which will connect to my one, which is already that one we done last time together. I think we this is work file, so this is the file. I think we some more stop here. Let it connect a little bit because it's an online thing. So one thing that one anecdote is about the code lab. Some of you may use the VS Code, right, to do the program, and some of other class people told me that one of the drawback of the VS Code is they may be conflict with the VPN program that you may be using. If you want to access to AI program overseas, right, in the US, where Hong Kong cannot access ChatGPT or other thing, you need to rely on VPN, and some of the VPN program actually conflict with VS Code, in case you don't know. But anyway, so that's why using the code lab will be good because everything is on the web. Okay, but this data, okay, this is same as here, or where we are. Okay, where the slide? Okay, so this is the one we see. This one. Okay, so what left is, okay, I want to do two things. Okay, I want to group things by different group, okay, based on the team manager, okay, and then what I'm going to do is I want to aggregate, means I want to find out the summary statistics, mean or those things, calculate numbers, okay. So let me try to copy this and continue our code, okay. So we have data already, okay, and the data right this way, okay. What I do is I want to combine together. Group by means I would want to combine when the column of the same team, same manager ID, this each manager given ID, and the manager name is same, okay. Then I would call it the same, okay. So let's see what you get once you group this, okay. You can see there's not much thing happening, but the same as this one, but they will try to is invisible. But if the same manager ID, and same team, implicitly they will be together. Then they can do calculation. So you can't see anything here yet, okay? But they will do calculation, okay, at the background. So that's why you usually do the group by, is to group them together, because you calculate things by group, right? So what you do is you calculate, okay, let's show you this and you will see what is it doing in this. Okay, once I group them, okay, and I do the aggregate, means that I want to look at some calculation based on the group. Okay, you can see what I've been doing is look at the same division, and then same size, and then look at how many games they have. Okay, that means that for this team, this manager paid this number of games. Okay, so that is what it's doing. Aggregate is adding up, right? Get the summary for that. Is that okay? Because I want to buy group, the same team, the same ID, the same manager, right? I want to look at that. How many games he played during the period. Okay? Just add them by group, right? Because you can't really simply add them up, right? But you want to fix manager in this team, how many games he played. Is that clear what I'm doing here? So first group them and then add up, because you only add within the group, right? The same observation, same type of thing. Is that clear what he's doing? Is that clear? I mean, as you request, I guess slower, right? But hopefully it's slow enough. Okay. So what I do is I want to group them again. Okay. But I want to calculate how many points they win, right? Because I want the one that win the most, right? The most successful manager. So what I do is do the same. I group them together and then calculate how many points the manager get and sum up. Okay. So by size means add up, count how many of them. Okay. And here I just calculate how many points, I do the sum. Okay. So aggregate is a very general function that you can do a lot of things. Okay. Dot sum just sum up how many points there. And the function size just count how many of them. Because before I just count how many of them. But now I look at how many points they make. Okay. I want to look at that. Okay. So what I do here is this games, it just count 1 or 2 or 3, but I want to calculate points. Okay. No, I copied the wrong. I'm supposed to copy. Okay. So that's why I connect the team, the manager, same as before, as group. Actually, I don't really need this line, but I just do it again to show the parallel. Then I just group them. I just calculate the points. Then actually you will see you calculate how many points each manager get. Right? Then you have an idea of how many number of points. Then probably later you will divide it by the games, and that's how efficient they are. Right? Is that clear? Because points means what? Points means if you win the game, you get 3, right? If you draw the game, you get 1. You lose, you get 0. So just like how many games you win, right? As for the team, for the club. Okay. And now here comes next thing is I want to combine that two data set, which number of games and how many points they win, right? Basically combining these two data set, right? This data set is very simple, right? This data set is just this 3 ID and number of games, right? And the other data set is just 3 columns and the points. I want to combine these two. So very simply, because they are exactly the same, then make our life very easy. So basically what you do is just games dot join points or points dot join games is fine. Doesn't really matter because the same is one-to-one mapping. So either you swap, it's fine. Either you games join with points or point join with the game with the same. Okay, so that is how you connect 2 tables, right? And if you want to collect more tables, then you keep going. Join. Fine. Okay. Of course, if one more complicated matching, that will require more complicated code, and the textbook doesn't include that. That means that I don't need to cover, right? So I just cover the simplest cases. Okay. So let's see how the join looks like. So this is once you combine. Oh, I should add this one head, right? There again, you can take a look at what's going on here. So you will see there's nothing very new here. You just basically append the other column there, right? That's how you join. It's join because same ID, you just join another column. So combine the same thing. Now we can do more operation, right? Calculate how efficient the manager is. right? We want to calculate, in principle, we want to calculate how many points that a manager can get per game, right? That is the efficiency measure. So, good. So this is how to define. Okay, we will create a new column. In Python, it's very simple. Unlike other software, you don't really need to define a variable and do it. You can just say, I write win, a new column called win ratio. Okay, just I define by definition. And the definition to define will be, as I said, is the points per game, right? It's how many points is one column over the other column, right? And once you did that, you want to sort them because from small to big, right? Oh, there's a typo here. This, I think the window auto, this should be the same small letter W because Python is case sensitive. Okay. Then you can see the data. Okay, let's see this. Let's run this. So now the first thing you do, you can see we create a new column, okay, by just simply calling it. Okay, I just don't need this line. Okay, and okay, and I sort them. Okay, and then I show the head. That would be the thing we do. Okay, maybe I just separate two steps. That would be, I think, we more maybe a little bit better. I add on one more step there. Okay, you try to run this. What you will see is not very surprising. It just you just divide this over this, give you this number. So that would be the win ratio. And I want to sort them. Sorry, I think I changed the code without changing this. It's a win ratio. Sorry. Okay. So they sort this. Maybe I should do descending. Sorry. I think I should have done something wrong here. Oh, this is sort from this one I sort from small to big, but maybe I should do the descending instead of ascending. So I should, instead of this, I should do ascending. No. Yeah, I do wrongly. Yeah, CMD, right? Oh, I know, I forgot. Because the Python, the force is first capital letter. So this is the thing. When I run this, you will see this guy is the top guy, right? And then followed by this one. Okay. So this is the top managers, right? Because this guy play one game and just win, so it's very good. Okay. But I hope this convince you how you can operate the top 10 manager. Okay. And here I just add another new slide. It's in the book, it said I want to exclude the first guy. The first guy only play one game. It's not very good, right? We need to require them to play more than 18 games. I think 18 games means half a season, if I'm correct. So they want to do is like try to take out only those people who pay more than 18 and then do again. Okay. And then see who is the top 10 manager. Okay. So let's run it again. Okay. You will see that would be more reasonable. They play more than at least enough games to be meaningful. Okay. So there's top 10 managers here. Okay. That's how this paper, but the case being studied. Okay. You learn how to have two data sets, in principle, to combine it, right? And then do the calculation and then combine again. Okay. You group them and then do the calculation and combine, and this is how you clean the data and do some analysis. Okay. And this, so this, the blue one, right? Now, the remaining little small part is what we call the, which is very important if you want to do careful analysis, right? But in the business world, usually probably you just don't care that much. But if you want to be very careful, sometimes these things can be very important. First one is if you download different data from different source, they can have different name, right? And they can be ambiguous, right? Because in one data set, they may be called Manchester United. And in other data set, maybe Man-Dog United, right? There can be different name for the same observation. So have to be very careful, right? Maybe say, suppose the data, some data will say South Korea. Some people will say Korea. Then you have to figure out how to handle that, right? So have to be extremely careful when you try to have collect your data. And this duplicate, of course, you know, right? That's not anything wrong. That is something which is something interesting. Is look at the data of the United Nations. The data you have each country, but after each country, at the end they have by region and also the world, right? This column have to be removed, right? Because they may useful for their own reason, but it's not useful for your analysis, right? Because they are not country by themselves, right? They group the region, right? Or they may have data of provinces or cities level, which doesn't really matter for your analysis if your analysis is on data. Okay? It's on the country level. The next one is very troublesome. Idea is the missing value, right? If the data from the database, usually don't have problem because some people will clean up the data already. The missing value usually is not a big deal. Of course, you combine data set, missing is always happen, right? But when you are IT manager, many often, they're not missing, right? You observe something, they do something at some time. They only look at certain web page or purchasing data, you only purchase something, right? Then many things are zero. Then how do you deal with it, right? For example, one very famous thing probably many of you may notice is Netflix. They want to know how to figure out the algorithm to improve the recommendation. And the recommendation is basically like based on what you watch, based on history, right? And then you watch, say, I watch film ABC, okay? Then I can rate ABC. But there's CDE I didn't watch. And other people may watch CDE, right? Some people may watch BCD, right? Not everyone watch every movie, right? Then how can you come up with a system? Not missing data, right? And one of the things that Netflix actually, they offer a competition, but this is back in 15 years ago. And they offer, I think, $1 million prize, $1 million prize, US dollar, to solve this problem, how to solve the missing value, right? Because apparently they're missing, right? Because you go to the website, no one to watch all the movie in the system. So you have to figure out some way to combine, right? And the problem, as I said, this is systemic, right? As I said, right? Because suppose I usually only watch comedy or watch a child movie, right? I don't want to watch something very serious. While, say, on the plane, I watch a kids movie or something very stupid. Anyway, to relax my mind. But some people watch a horror movie or some crazy, tense, exciting movie. But anyway, so you look at my data, I would just have something look like kid, right? Because I look like kids movie, or Friends or something more stupid thing. But it's lesson bias, right? So the problem is, as I said, is a imputation fit the value. Okay, how to solve this problem? Or you just omit it. Okay. So, but this can drive your result. Have to be very careful because missing can change your result a lot. Later, when you try to run analysis like regression, those things can skew your data a lot. Okay. So have to be very careful how to do it, right? Suppose you train your system, right? You do a machine learning algorithm. Do you allow your data to be missing value? Right? You try to train your system. If the data has some missing value, some data miss this column, some data miss this column, do you need to omit this observation from the training set or not? Right? Because that will change how you tune your data, right? So these are very important. I mean, of course, it may not be important for simple regression, but when you try to build a complex system, machine learning system, what are you going to do? A lot missing, right? As remember, garbage in, garbage out. Machine learning can solve this problem if you don't have nice data, right? So that would be an issue because AI always give rubbish because you fit in the rubbish thing, right? Anyway, as I said, this is the data usually we see, right? Can be man city, man dog city, can be man united, anything, but that's why they will use team ID, right? Instead of the name. So one of the big challenge of cleaning data is from text data, right? Because text can be in anything. You have to figure out how to map to the ID that would be meaningful. And that requires a lot of work, right? Because there are many ways can go wrong. I mean, not a number, right? Depends on the system, what they give you can be very challenging, especially IT data, right? People write review, maybe them spelling mistake, recommendation, the spelling mistake, how can you do? Right? No one checked the data input, right? Especially the free text input, right? How do you comment on the product, right? I have to be very careful. And one thing, there's a lot of things had many common steps, right? You want to write a code to clean the data. That is very important. I mean, probably your IT manager, I don't think that's an issue for you, but you know how to write down step by step because you don't write comment on your code, then you lose it, right? Same as clean data. So that's why using Excel to clean data is not recommended. No matter what operation, you shouldn't clean the data in Excel. Okay, you should always start with the raw data CSV file, clean the data using your program. Never use your Excel to clean anything. Okay. Then, I mean, of course, I mean, you can do it. I mean, no one stop you doing that, but that would be hardly strongly advised against. Okay. And then you want to draw a picture of the data set, right? Look at the data, look at the head, look at filtering, get some idea whether you are missing there, do the counting and see everything is all right, right? Especially you may not know there's a missing value, right? You can count there's an NA there, you're very important. But not going to every single line, but if you have time, you can take a look, but there's common mistake. But when you do the project, you know, okay? This is not something that I can teach you one by one. You have to actually work on some problem, then you will know how to work on that. When you work on project, come back to here and take a look what step you should observe when you do it. And it's like learning by doing. It's like riding a bicycle. So you fail several times and you know how to do it. Okay, of course, I tell you the secret or the common step. Everyone tells you that, but you never listen anyway, right? You just fall. And then you make a mistake and then you learn. Okay. Some idea how to clean the data. That is usually I also advise this is a nice way to do is you have to remember you have the readme txt for always to explain how you collect data, how you clean the data, what's the name of the variable, what is it measuring, how you clean it up. Everything, the raw data must be saved separately. And then you have to have another file that collect the clean data, which clean up. And then you analysis is separate. Okay, so that's why no one use Excel. You should never use Excel. Because Excel combine your data, your analysis, the result at the same time. I mean, it's good when your data set is very small, but it's never a good idea as an IT manager, right? Right? You do Excel, that seems to be too low, right? So this tell you the data structure of the football thing, which is downloadable on the web. So you can take a look at how he organized the data. And this is also something that I figure out that is after several years of working on data, these are very important. Of course, every company may have the code how to name stuff. If you don't, then you can name in your way. Then if you name your way, then you tend to have too much freedom, then always end up with disaster. So have some guideline we good. So like this, right? Make sure that your name the file should be readable. There's no space. Okay. Also, machine readable. Try to use hyphen underscore. Same as you name your variable name. Don't call X or Y or ABC. That would be crazy to read. Okay. Have to name variable by the name that is meaningful. You can read it. Other people can read it. Okay. And also yourself in the future, right? And then pack the numbers, right? 02 instead of 2. Use the ISO format for the date. Seems to be very kindergarten style, but these are very important. I can say, okay, as experience. I mean, for me, I'm not, as I told you, I'm not a trained econometrician or statistician. So, but I learned it by myself. So that's why I make a lot of mistakes along the way. But when I read this book, okay, yeah, they are also commonly mistake that I have made, and I learned it by mistake. But hopefully you don't follow my footstep. Okay, so we finished lesson 1. Okay, so lesson 2, just very briefly, I have 1 minute, but very quickly go over what we're doing, and then after the break we continue. We will cut the breaks a little bit shorter. So this is going to be talking about what we call the EDA, exploratory data analysis. So basically just trying to get some idea of data. And why? Because if the data clean up, then we still want to see whether data is meaningful or have some idea all about data, how to do analysis, right? Because of the data, where the mean there, where the data is skewed, or symmetric, whether the data looks like, whether there's the data representative, right? Whether data fit what our prior knowledge, right? And whether it can tell us whether data representative, right? Whether the data actually is the right thing, right? Do we have all the observation that we need? Is it each category have enough observation, right? Suppose you collect data of China, it's consumer data, right? And then suppose you only have one data from Xinjiang, then probably you should, when you know it, then you should probably either collect more data from Xinjiang, or you just say your data doesn't include Xinjiang, right? Or particular area, right? Or if your data is mainly the female data, no male in the group, or very few male in the group, either you just say, I just drop all the male, just focus on female, or you should collect more data on male. Or you just say, okay, it's true that maybe this is the consumer data for maybe cosmetic. Only most men will not buy, only women buy. That's okay. Okay, you fit what you know about the data, that's fine. Okay, if it doesn't fit what you think about the data, then you have to be very careful, right? So that is exploratory data analysis. And the second one, which is topic chapter 4, is about correlation. Okay, correlation is about, as we said, is a cause and effect. But that is a one step before the cause and effect, right? Because the main thing of the data we want to discover is causal relation, right? How X change Y. That help us to make business decision, right? Or you want to see, as an IT manager, right? You implement some new feature to your product, to your website. You want to see how the user responds, right? You want to see how this will do that, right? Because you control this, the causality is done, no problem. Because you do this first and how people respond, then usually there's not a problem. What you find, the correlation is actually causality, right? But still you have something changing in the background. So causality is not immediate, right? So maybe there's something changing in the background. So so that's why we are very humble. At least at this stage, we focus on correlation. And at the very last class, last 2 classes, we'll tell you how to identify or how to figure out the causality, cause and effect. But at this moment, we just tell correlation, how 2 variables change together at the same time. Okay, whether X increase together with Y. We don't say X cause Y, but they move together. Okay, we don't know, but it happened, right? Is that clear? Okay. So that is right. We describe things in the data, right? Try to summarize it, how to describe it, and try to uncover the association. So this is the two chapters about. Okay, let's have a break of 10 minutes. Maybe 12 minutes. 12 minutes. We can have 12-minute break, a little bit longer, but not too short. 12 minutes break, and then come back. So let's resume at 3:30. And in the meantime, if you want, you can fill in this to let me know, is it too fast, too slow? So we'll resume at 3:30. In the meantime, I walk around to see if you have any question that I can help. Well, let me know, is it my English is still too fast or it's okay? 我也跟你一样，这个家里微信不用，我觉得这个很好用啊。对，这个是很好用，这么好用，我都用习惯了，这个比较好用。用习惯了，但不是用习惯这个就不会。我一直不会用这个 Mac， 我在美国的时候，它是对电脑好，什么都是用 Mac 用这个歌只有自己打个其他的。真的很不错。对 Windows 是一个很难，但是苹果上。对吧？反正就是每个都是，在美国的话，所以基本上就是以前的，在亚洲的话，大的没有，但是我都是在。这里面这个我都找我自己喜欢的。我再卖，对，都得。有一些下载会效果，后面你找到。啊，这个那个会讲一下，大概是感觉是。真的，那稍一点点，而且还是两层那块。有一门课程发的，这个老师的，那么有两节课程，你发错的只有两节课程。另外一边所以主要国家的这个 foundation 这个， 白的，没什么，到时候就明白了。这个里面你的一级界面就是一期生两回合，三级大题。你现在看不明白再讲一次。可以不讲。我连怎么考这个有没有？应该还为什么？我边边选择那个，我就这个，我也不记得。对，就应该你们那个比我很容易的可以，所以他们说抓好。我也相对来说现在so let's see the response so far, and then we can see whether we need to adapt to our where. Okay. So I can see it is that the speed is medium today. You can catch. I can catch you. Okay. And please leave here at 2:30. So I recommend you to get some coffee like me. That's what I do. I mean, I got a big coffee. Uh, a tea would be useful. How can I learn this class better? I don't know how to learn such a course. Two things. One is at least try to follow the Python code that we run and understand what's going on. Of course, AI is so convenient. If you still don't know what's going on, just copy the code to AI, ask them to explain. That would be the easiest way to go ahead. But you can just copy. I think I explained. But if you think it's still not enough, AI. Okay. Of course, always AI doesn't work. Ask our TA. Hopefully that would solve the problem. Or of course, if TA AI doesn't work, final is me, right? I'm going to answer your question. Okay. The first one is code. The second is later I will give some assignment. Then you will know what to do, right? That is working on the assignment, then help you to see what will be asked in the exam, right? Or what is important thing, right? And there'll be some quizzes that try to make you understand what's going on in the slides. Okay. Hopefully. Okay, I still have someone saying too fast. I don't know if English too fast or material too fast, so probably try to be a little bit more specific, but I will try to. How can I speak English? Oh, I'm not very fluent, but to be honest, I think my English is like medium in terms of Hong Kong professional people. Because not to say anything, but grew up in the school where the village area. I mean, so that's why my English is not very good. But useful. It still can be fine. None. Put Python. Okay. I will try to do that. But it's already here. This slide is already this file is already in the in the Blackboard. But I'll try to do that. Okay, I'll try to do that. Haven't enough time to understand the code. So basically the code you do is basically calling some function, right? Just like you have an app, you press this one, this thing comes out. So the only thing is you press this guy and you just change the variable name there. Okay, you try on your own project, that would be hopefully that would be okay. And again, I mean, you're IT manager, so if this is difficult, then it'll be very difficult to become an IT manager. And so hopefully you can crunch it. Very surprising. Just to remind, today is Wednesday, not Thursday yet. So But I have other class. Everyone, some people think it's Friday because of leftover effect from the typhoon. People still keep thinking it's Friday or hoping for Friday is a holiday. Yeah, that's good. Sunny now. For yeah, Python to join. Yes. Tidy. Don't use Excel to clean the data. Yes, that's I recommend. Please don't do that. Because you don't know what you have done. This because Excel has no record. Okay, you don't know actually what you have done. So please don't use Excel because you are come on, you're IT manager. Don't use Excel to clean data. You'll be ashamed of doing that, right? Yeah, Panda function. Yeah, yeah, it's too low. Yeah, don't use. Or even if you use it, you say you claim to. Well, if you use Excel, one thing is you use Python to control Excel to do the cleaning. That would be slightly better, right? I think there's a if you know there's a Python that can ask operate Excel, that do things that if you really like Excel, wait, that would be good. Actually, this is also good for business because a lot of managers don't know how to look at Python but they know how to use Excel. So if you still really want to use Excel to showcase or whatever, you can put everything on Excel. I think that's a package. Or I can't recall. Excel, Python, library. What's that one? Yeah, open. So this is open. I think this is one. There's some package. I think this OpenXYL. Yeah, I think this is the package that you would able to where's the website there? So they can you can see open a workbook and write down where they are and add and then input things. So you can use this thing to create a worksheet of Excel that you can show to a manager, right? Because you always write everything on the Python, but you want to showcase to your boss, which only read Excel. That is the way to go, right? Because you show them the Python output, then probably he don't like it because he can't really read it, right? He can't really check your code, but you can automate that. Okay, so far seems to be okay. Most of the people is here. Of course, I lost some of the people. I'm in the middle, but I will try to be a little bit slower, at least at the beginning, to make sure the speed is okay. So it still means that speed a little bit fast or try to slow. I try to be slower a little bit. Hopefully that makes everyone happy. This is a good joke, I guess. It's easy to get sleepy when you are full. Oh yeah, that is it's very scientific because but the problem is you eat carbohydrates. If you eat carbohydrate, then your red blood cell actually go there to digest things. So try to avoid carbohydrates when for lunch. Okay, you can eat a lot of protein or fats. That is okay, but carbohydrates should be avoided. For but now I mean I'm old enough, so it doesn't really matter to me. I mean whether the matter. Yeah, clinics is important. Daily for analysis. Yeah, you're right. Even IT manager. Yeah, IT manager cannot solve everything, right? If IT manager solve everything, then we don't need other people, right? So IT manager only solve IT problem. Uh, so yeah, sorry for that. Uh, same. The same. Are you the red one last time? Okay. Next time I wear black. I have black and white. Blue. Yeah. Wear same. Uh, I don't know. I can't recall. Did I really wear red last time? Maybe. I mean, I like red, so maybe I should remember. I should do the blue or black. Maybe black, right? No, I forgot. That's okay. Um, let's do the EDA. Okay. What is EDA? Is try to do several operation there. Okay. And what we do is to check the data and try to answer some simple question. Actually, we did something in the football data, right? Actually, we did do some calculation and sort that out. Actually, that's part of the EDA, right? Although they didn't say it out, but that is EDA, right? You try to check where the data is missing, right? Because from the data we just seen, sorry, I just low. The data just seen, there are some manager, they only play several games, 1 or 2 games, but we haven't taken them out, right? So that's why motivate us to filter the data such that only manager that play more than 18 games should be retained in the data set, right? So that's why we are doing this exploratory data analysis. And the thing is, we want to look at the key variable and how they look like. What is distribution? Is it extreme? Is it evenly distributed? Are they we have missing value? And then how they look like. And we will do 2 types of analysis. The first type is descriptive, or the graphical. By graphical, we means draw histogram, draw bar chart, pie chart, what you learn in the elementary school or kindergarten. Well, no smiling, kindergarten thing is the good, best thing. Why? I think the one quotation from one very famous people was the most useful thing in schooling is you learn in kindergarten how you play along with others. Okay, that's the most important thing to be successful in your life, right? Especially you come from Asian culture, you know, connection is the key, right? How to deal with your friend, how to deal with conflict, right? You should learn in kindergarten. But anyway, how to draw graph is most important for business decision, right? Because manager don't run regression, right? Look at scatter plot, look at group of bar chart, pie chart, right? You're a manager, IT manager, right? So suppose the regression thing is done by your staff. You read the table, you read the Excel, right? But you have to know how to do Python, right? Otherwise, you don't know whether your staff is creating rubbish, right? Garbage in, garbage out, right? And beside that, you need to know how to read some of the numbers that generate based on standard statistics technique, which is the mean, variance, standard deviation, kurtosis, skewness, IQR, all those measures to look at the data. Okay, so the first we go to look at graphical analysis. Okay, graphical analysis thing we do is we focus on frequency, look at how often number they are. There are 2 types of frequency. Either look at the absolute, which is number, how many of them, or they can look at the relative, which look at the percentage. Either way will work, depend on your preference. Okay, and absolute actually have more, you give you more idea actually actual number they are, but relative will give you some sense when you compare across data sets. And it depends on the data, whether your data is discrete or continuous. Okay, by discrete means that the data have finite number of possible values, right? Suppose the star of hotel, you have 1, 2, 3, 4, 5, right? And continuous night money, right? The price of a good can be $10, can be $11, right? But can be $10.50, right? $10.10. Any number in between 10 to 11 can be admissible. That's continuous. Why? Because when you plot the data, you have to plot them accordingly, right? Because continuous, then you have to group them. But for discrete, you don't need to group. We may also group it, but naturally you don't have to group. So that's why it really depends histogram or density plot. I think you learned that in your college, high school, or kindergarten, but let's check. Okay, and what to look at it is where is the data look at how spread they are with the extreme values, okay? And let's do this based on a case, and then you know what we are looking at, okay? We look at the hotel case, okay? Remember the hotel case we do in the topic 1, right? Where you look at a European city, Vienna, right? In November 2017, I remember. So something like November, and then look at a particular day, and then look at the distance from the city center, the price, the hotel rating, so on and so forth. Okay, this is the data. Okay, and then we want to see histogram. Okay, look at the price. Okay, okay. We will try to generate this using the Python code, but let's look at data first. Okay, and this is a data where it is a, you don't mind if I close it? This absolute count, right? You can see is counting how many frequency they are, right? The stars, right? Because they're discrete. So that's why we have the histogram, right? Because you never have, you only have 1 star and 1.5 star, but you don't have 1.2 star, right? So that discrete is good to a histogram, okay? It's absolute. And this relative, right? Gives an idea. So you can see from this diagram, right? Most of them are 3 star to 5 star, right? And then you have 1 and 2, then probably there, but probably you might want to exclude them from the analysis, right? Or you may want to collect more data, right? If this fit what you think, if this city you think from the prior knowledge is mostly a 3 star to 5 star, then the data is fine, right? But if know this city is a city from middle of nowhere, okay, then this data is not very representative. You shouldn't use this data, right? So that's the idea why you want to look at this data, because the data have to be meaningful, have to fit some kind of criteria that you know something, right? As a manager, right, you would see someone give you this, then you should know, okay, this data fit your industry knowledge or not, right? If not, then probably you would think anything come out of this data set would be rubbish, garbage in, garbage out. So have to be very careful, right? Everything have to fit in nicely. And this is the percentage, right? And the other thing I want to look at is here is the histogram is it grouped them together by bins. Okay, here is prices, okay? Because price is continuous variable, right? I mean, of course, $1 is $1, $2 but you have 50 cents, right? So on and so forth. But you can display every single data there, right? Look like this. It's a bar chart, right? Sometimes they call, but you can call histogram anyway. But this is the shape, okay? And of course, this is what it is, but it's not very useful. It's very detailed, okay? But it doesn't tell you too much. This one, you group data by $20 bin, okay? Put a bracket, $20 in the same thing, okay? And then you group them together. This group data tells you something more interesting, right? You can see the data is highest here, then go down, okay? So you would expect most thing is around $100, right? And then if you're paying for this, then you must have a lot of money, right? So most likely it's here, and then you find somewhere here, maybe a good one, right? If more than 150, probably you're overpaying, right? If you're paying 50, then probably you're going to the very cheap hotel, right? So that gives you some idea. Does it make sense, right? The first, something you keep in your mind is, do you still want to keep this data point in your data set, right? Looking at this, you identify the extreme value. Remember, one of the goals of doing this is we want to look at are the extreme values, right? Then you may want to filter them out, okay? When you want to do calculation, when you do analysis. So look at data is very important because if you don't look carefully, then it will be a problem, because when you look at the undergraduate textbook, they directly jump to analysis, right? They don't ever tell you that this pre-step is actually even more important than analysis, because everyone can click the button to calculate the mean, to run the regression, run everything. But how to clean up the data to come up with the meaningful solution, that is something that requires a manager to do it, right? Manager have to tell you have to make the decision whether you keep this or not. That's a manager job. Okay, how to given the data, how to create instruction, how to clean up the data, how to clean the missing value, and the analysis is the analyst job. Okay, which your manager, you don't have to deal with too much of that. Also, you have to understand what's going on, but the key part is how to pick up the right thing. Okay. And the other thing is you try to look at the beans is a little bit better for the beans, and actually the shape looks a little better, right? And this is showing you is not symmetric, but there's somewhat positive skew in this way, right? It's not a symmetric shape, right? It's like this. There's some positive here, some outlier here, right? And you look at this $80 beans look like this as well. Okay. So what we're going to do now is go to Python again. Okay. We go slower because I have a feedback that I'm going too fast on the Python. So go slower. Let you copy and paste. Okay. Now, what we do, because we do data analysis, we will go beyond Panda. We need a package called NumPy, which is referred to numerical Python. Okay, so another package, which we will do NP, which is fast computation for large matrix. Okay, that is already in the standard package in Anacodia or other scientific package. So it's a common package there. So what we're going to do is Panda, we know very well, our old friend is handle the data, right? Handle the CSV file. So what we're going to do is first have the URL and use panda.csv, which allow us to, if your internet connection, to download the data directly. And it will be stored in a DF as a data frame objects, which can be used. Is that okay? And then, because we only care about hotel, so what we do is look at this data frame, look at the keep the row, okay, such that the column type of accommodation is equal to the hotel. So only filter observation that is hotel, because the data set, remember this apartment, they have a Airbnb, so on and so forth. We want to keep hotel. So these are the code. Okay. So let me copy and paste, and I will give 20 seconds for you to do it, because some of you tell me that after I copy, I should give some time for you to copy as well. So the good thing here is I can test here. I can have a title is topic 2, or class 2. And then I put the code here. Okay. So if you want, I can look at the hotel doc head at this one. Then I can check out what's going on there. So as I said, I will have 20 seconds of waiting before I talk again. Is it okay? So if you have a question about the code, let me know. Hopefully you get the data again, because it's the same as the topic 1. Is that okay? Okay. And if your iPad, you still can use it, because iPad can also use the code lab anyway. So if you don't have the laptop, you still be fine. Is that okay? Okay. So since no one complained, I assume this is okay. Okay. So let's continue. So what I'm going to do is look at the prices. Okay. So what I do is, this is a data set, right? I just need the price data to draw histogram. So what I do is I pick up the column or the whole data set hotel, I call the price vector. The price, if you remember, if here there's a many thing here, right? Go to the very end. I think that the price price is here, right? This column is price. Okay. 1, 2, 3, 4, 5, 6. The sixth column is the price, right? So I'll try to look at the price. Okay. So what I'm going to do here is I take out the hotel, the column price. So this square bracket is called subset function. Basically, at hotel, I take out the price column and I store it as a price, which the name I give is list of the prices. Okay. So don't confuse this price and this price. This price is just the name of the column, and I store it in a variable called price. Okay. Let me do this first. Okay. Now, let me do this. And I wait 10 seconds. Okay. So now you would wonder, what do we have? Okay. The good thing is look at the variable here. The left-hand side, there's a variable here. You click on that. Just wait a little bit. You will see actually the price is here. Okay. You will have a called not data frame, but series. It's a because it's a single dimension. It's a series. And this series you can try to plot. Okay. We use the price to plot. I don't need that now. So what I'm going to do is to create bins. Okay, histogram requires bins. Okay, bins is the bracket. Okay, if I want to show individual, the bin size is 1. If I want the bigger is 10, 20, 40, 100, you will try that later. Okay, and then what I'm going to do is now I have to use the NP library. Remember, NP is what? NumPy. Just go back in case you forget, because this shortcut is always NumPy is always NP. Okay, it's almost without every single software demonstrates NP. Okay, what is A range? Okay, basically what it's doing is you have the minimum, the data, maximum of data, right? And you want to divide that based on the bin width. Okay, and because of the way the code is being written, you have to add the last one to the bin width to make it work. Okay, so let's see, then probably you understand why we do that. Okay, let me create this one. Okay, then look at the bins dot head. No, there's no head, just bins, I think. Okay, so basically, because by 1, it will be 1 by 1. Okay, it's creating a vector of all numbers separated by 1. If you change to 10, okay, you run it, you will see everything is separated by 10. Okay, because of the way A range is being written, you have to add the last one to include the last guy. So that is some tricks about the A range. Okay. Now I go back to 1 first. Okay, you can try later, but let me wait 10 seconds. I hope it is okay. I guess I need to have some time because some people use iPad, then copy and paste is not that easy compared to the laptop. Now what remains is we need another package. I'm sorry, we have many packages to introduce today. We have a NumPy. Okay, This is the package called Matplotlib library. Okay, mathematics plotting library. Okay, this is there's several things. Okay, first is the Matplotlib library. This is the very big library that how to plot stuff. Okay, and this pyplot is the one that do the regular plotting. Okay, and this is the plot that used in statistics in general. So basically, this is the one that we use. Okay, and the shortcut we use is PLT. Okay, and as you can see here is I would call a histogram of the prices, and I tell them how to group the data by bins. And then I will tell them what is the X label, what are the Y label, what title I want to show it. Is that clear? Each line. I mean, that should be something that is not something complicated. Okay, let me try to do it. Here. Let me run it again. And if I try to plot this, it'll be something like this, the same as see in the book, histogram, right? Of course, you don't like the histogram, maybe you can write a price distribution or hotel price distribution if you want to be more exact, but or hotel price in Vienna, right? Something like that, whatever you like. Now, if you change, go back to here, I change to 10, right? I make the bin is smaller, okay? And I rerun this again. This gives me another table, right? That is like this one, right? So you can try 20, 50, 100. You're able to see the graph that given the slide, okay? The slide, the graph is given in the textbook, but you're able to create it in your own style. So I give you 20 seconds. You can try to see if that's okay. Hopefully able to do that. No. Good. So you can see histogram, and you're able to see this outlier there. It's not symmetric, right? This is something you can observe, and you can tell people already, right? This is as a manager, right? You see the data, this is already from the shape is already can do something on it, right? Right. If you are the manager of the price comparison website, is this data meaningful? I mean, your customer, so you show this result to your website, right? I mean, if these are appearing too off from your website, you show this to your client, to a customer, probably you just waste their time, right? So this is, as an IT manager, you can see this thing, right? If this is the data from your website, right? You probably see, suppose you want to, right, work out this, right? Then probably you want to make your search result focus on this area, right? Show this to your customer on your website. So this is the algorithm that you can consider based on data, right? The data tells you, okay, what kind of things to show, right? Some adjustments, some customization, right? You can implement this using the Java code, right? Is that okay? Good. Now, good thing, because we learned a lot today, right? Because we learned the Matplotlib, we learned the NumPy, we learned the Panda already, right? So in your CV, go home and can write, I know Panda, I know NumPy, we know Matplotlib, right? Then you can tick many boxes from today, which is good, right? Because increasingly in this class, you learn more and more package, right? Then you're done, right? Because this is how you learn Python, right? So let's continue. This is another table, but not the price, but this is distance from the city center, right? So you can see these are very close to the downtown area, and these are too far off, right? So then you can see that most of them are very close or very far away, right? So when you do analysis, think about that. Do you want to keep this data set, right? Or you want to focus on this one? Okay, depend on your nature of the study, right? But you decide what to keep, what not to keep. Okay. And in this case, we just try to do this, right? Hopefully now it becomes familiar to you what we're doing here. The first line is to take the column of the distance, to save it as a series called distance variable. And the next two lines is try to create bins using the M.P.A arrange. Okay. And whether it's 1 or 2 or 3, up to your choice. Okay. Since it's so simple, I just copy the whole thing and put it here. And let me close it. And let's draw this diagram. I think that should be something, the same thing, right? Use the same code, except that the X is different, right? Because now it's no longer prices, right? And then this is distance. Okay, there's only two different things. Then let me copy and paste. Since there's no new addition, I just put in the same code. Putting in the same is better because when I change this, I just run once. Okay, so that's how you group the code together in a meaningful chunk. So it's the graph looking at. But if you don't like this, you can group by say 2 miles. Every 2 miles like this. Okay. Or you can put 0.5. That can also work in other way. Okay, depends on what you think should be grouped together. Okay, maybe I give you 20 seconds if you want to copy this code and run it by yourself. If you don't have your computer, you can peep to your friends and see how we're doing. You understand how the code being work. So if you don't have computer, as long as your friend has computer, that should be fine. Is that okay? Is there anything I can help, or it's okay? It's okay. Hopefully now it's not too fast. Or if it's too slow, let me know. I can speed up, but let me keep this current speed if that is not too bad. Is that okay? Because this class is more hand-on class. You make yourself working because I think you're very tired after the carbohydrate meal, right? Many are very sleepy. Maybe you're watching the football, right? These days, so make you can't sleep very well, right? I don't know. Have anyone watched the football game? Yeah. Saudi Arabia versus the China. I don't know whether you watch it, but those who watch it can't sleep very well, as far as I understand. But anyway, so it's okay. Yes. I haven't do this yet, but I think it's because of the bracket thing. Is it working? Oh, it's working, but there's no result there yet because it's running. Okay, now we are going to the next one. So what we're going to do is to filter the data, right? That is very standard because we only want to keep the 3 or 4 stars and run that again. Okay, so what you want to do is to filter the data and look at the prices again. Okay, so what we do is combine what we learned in the last class, the first class, fill the data. Okay. And fill the data means I cut it out. It's called hotel desk cut. Okay. Why I name this way? Cut is cutting. It's not I make this name. The name is made by the textbook guy. Okay. And I cut it is based on I select the row such that they're hotel and they're more than equal to 3-star, and they're less than equal to 4-star. Last thing is very important. Something has no star because they're not hotel. So I have to say they are not NA, or that some hotel not available. So this is not NA is very important. If you miss it, then probably you don't filter enough. So I mean, NA have to be very careful. Of course, if all the data has nicely done, you don't have this line. So dot not NA means you pick up things that are not available, right? There's nothing. There's something there. Okay. If there's nothing, you filter it out. You don't need those data. Okay. So this is hotel cut. Okay. So run it. And let's try to check if you're doing something nice. Okay. Remember our DF is the original data set has 428 observation. Now our hotel cut only have 200 observation. All right, so cut it by half. I don't know whether you can see it, but you can check out it's 281. Hotel cut has 281. Okay. So you're basically actually cutting something, right? So cut half of data set, gone. Now what we're going to do is nothing new, but redraw a diagram. Okay. This is the part the same as before, right? I think there's some typo here. It should be hotel cut. It's a hotel because we cut the data. So it should be hotel dash cut, right? Because we want to look at the cut one. And then we want to show your diagram here. Okay. So let's put it here. Okay. So this hotel cut. So what we can see is, okay, a little bit different, not the same graph. Okay. But this is the one that together with this, right? We are cutting the data, okay? Fill in data and look at it again. Even if you focus on hotel and 3 to 4-star, you still see that one there. Okay. Of course, sometimes you may want to add something like, I want to focus on the price that is no more than 500, right? In that case, you may add things like the following, but in case, but I'm not going, but I will erase after I do it, but you may try to say, okay, DF say price, right, less than 500, say suppose. Then you would cut the data that is more than 500, right? That's cut an outlier, right? Because in average, the price is 100. 500 is 5 times the average, probably is not the main concern of when you try to pick up something important. But I'm not going to do that now because I don't want to confuse you when you read this thing. I just do that. Okay. So you can add as many criteria as you want to filter out the data that actually fit your purpose of your study. Is that okay? So look at the graph, can tell you whether data is all right, fit what you think, right? Or you need to collect more data, right? So on and so forth, right? But at least looking at the shape can report a lot of stuff. Is that okay? Let me know if you have any concern. If not, then very good. Now we come to summary statistics, which you have learned in your first year in the college, if you ever learn statistics at all, right? Mean, median, mode, right? Percentile, quartile, range, interquartile range, variance and deviation, coefficient variation, skewness, kurtosis, all things are learned in your year one in your college. I taught this morning because this is what I taught in first class in statistics. So if you need anything, then email me. I can email you the my undergrad slides. Then you can learn a little bit more, but I assume this is okay. If not, you can just ask AI what it is, but it shouldn't be a big thing. I will explain a little bit, but something you shouldn't be. Maybe explain a little bit. It shouldn't be an issue. So we'll do it intuitively without going into detail how to do calculation. Because exact formula is something you should learn. I just try to tell you what are the meaning of the purpose of doing that, right? So the first one is the central value or central tendency, or where the data is, right? Usually use this to describe the data if you only allow to use one number, right? Let's say if a data set, I only allow you to use one number to describe what it is. That is the data, that's the number you give me. Mean, median, or mode, right? Mean is what? Mean is just average, which is adding or observation divided by how many of them, right? That's notation. Summation of xi over n, right? Suppose I have data 1, 2, 3, 4, 5. The mean will be 5. The mean will be 3. Why? Because 1 plus 2 plus 3 plus 4 plus 5 over 5, which is 3. Okay? And median doesn't involve any calculation in general. It means that the exactly middle guy, right? Suppose you have 100 people, or maybe easier, 101, not 101 people. The middle guy is 50. Oh, no. No, you have 99 people. Exactly the middle guy is 50. Because on the left is 49 guy, on the right 49 guy, 50, right? If you have 3 people, the middle second guy is the middle, right? So the median will be exactly the middle guy, or average of the 2 middle guy. So exactly middle. You sort them out from the smallest to the highest, right? Mode is the most common data, right? So we just look at data, look at basically the figure, draw the histogram, right? Which is the highest one, right? This common histogram, right? The highest one is the mode. So these 3 number is the standard thing you give the people if you use one number to represent data, right? That's why they call the central value or the central tendency if you look at the textbook, right? And these are called the spread data. Okay, it's how diverse the numbers of the data they are. This is the second number that you give your boss or the client, the customer, if you care, right? The data. What it is it's measuring how the data is spread out. And what's the use of it is trying to tell people that how good is the number you give me? How good is the mean or median or mode represent the whole data set, right? If the data is very spread out, the mean and median or mode is not very useful measure because they're all very spread out. If these are not so big, then the mean and median mode is very good. So basically, you can imagine this is accuracy of your mean, median, mode. Okay, and there are many measures. The first one is very simple range, largest minus the smallest. In the quartile range is like the following. Imagine your data is a loaf of French bread. Okay, French bread is very long bread, right? You use a knife to cut in the middle. That's the median. The median cut the bread into 2 halves. You use a knife to cut the middle again for the first half. That is called the Q1, lower quartile. You cut the middle of the second half, which is Q3. Okay, the distance between the Q3 and the Q1 is called the IQR. Okay, so instead of the biggest and smallest, look at the third quarter and the first quarter difference. That is called the IQR. Okay, and these two variance and division probably you know very well, right? The first one is called 方差, and this is 平均差, right? Variance is every observation minus the mean and square it over n, right? So basically you're talking about every observation, you care about the square distance from the mean, average of this square deviation, the mean of this one, okay? And this is 10 square root of that, right? That's nothing new, but just measuring how each observation differs from the mean. Okay, measure the bigger the number, the further away this data from the mean, right? So this focus on the mean measure. Okay. And for the skewness is look at data with a skew level, right? The way to do that many way, but this is the easiest thing you can think of is just the mean minus the median over the SD. Okay, that's the easiest. Okay, of course, it's not the most useful, but for our class, it's sufficient. Okay, because if the mean is bigger than the median, which means that it's positive skew, right? Just like the hotel data, because there's an outlier there, right? There's a very big number there. The mean will be large, right? But the median will be not so large because median is the middle guy, right? Even though there's a lot of rich people, which expensive hotel is not going to change. Okay, so before the break, I want to show you in this set of functions. Okay, then there was a break. Okay, in this, what we do is to introduce you a very basic library called statistics. Why it is good? Because this includes the basic Python. You don't need any package. Okay. After the break, we talk about another package we call Science PY. Okay, which will be slightly a bit more complicated, and we will use NumPy to do calculation. But statistic is there's some typo here, sorry. And that will give you all the calculation. Okay, you want mean, you can use statistics.mean. Okay, and median, mode, range is the max minus the mean. You can calculate quartile, 3 quartile minus the first quartile. That gives the IQR. You can have the variance and standard deviation. And with the P and no P is the population version and the sample version. The population version is over n. The sample version is over n minus 1. And the reason why this is what we call the unbiased estimate seems to be 无偏差估计, something like that. If that rings the bell. Okay. So let me quickly do this. This is this line x equal to that is creating a tuple, right? If you learn Python, right? Just create a list that you can do operation. Okay. So let me copy and paste, but remember there's a typo here. Just make sure you don't run this. Okay. And then we'll break. So do note that the Python only give you the last output. So I mean to be more meaningful, probably we just run this would be better run one by one. This is the mean. Okay. And if you run the second one, this is the median, so on and so forth. Okay. And then you can do the rest, but I'm not going to do one by one. Okay. And the only thing I didn't explain is mole and multi-mole. Okay. Mole will only give you, if there are more than one mole, they will give you a lot smallest value, like Excel will do. But multi-mole will give you a more than one, then you give you the more than one mole. Suppose it's 1, 2, 2, 3, 4, 5. Maybe I just demonstrate that. My data is suppose X is 1, 2, 2, 3, 4, 5. And I have a data maybe 3 feet. Okay. In that case, they will give you two number there. It's multi-mole. Okay. If you do the decimal, then it will if you do this, if decimal, then it will just give you the single mole. It'll give you two. So you should use multi-mole whenever possible, right? Because unless you care the smallest number. Okay. But of course, the multi-mole will give you not a number, but at least the number. Then you have to, when you do the programming, that to be a little bit more careful. Okay. But otherwise, all these should be very well. Right. So let's have a break of 10 minutes, and then we come back. Let me know. Okay. So maybe I end this one. Then I have a so a second break. The second break, a second set of questions if you care to enter to tell me how well you are doing. But if you are tired, you can just lay back. Okay, you can lay down and relax. But if you want to tell me something, you can just feel free to do it. Okay, there's a break, and then we soon come 10 minutes later. Okay, fine. Bye. Yeah. 现在这个大家都练，要不然当主播。没办法，在上在在他们学校去做，在上哪个地方？科学分析怎么带货来的？多一点科技基础的话，带货也比较好。我比较喜欢。地学是多的，看挺多的。对。
对的，从来就是每少一点点，凡是那个经济不行，大家都来出来。所以我这几页大概就把那个经济周期，外面好的时候我们就不行，外面不好的时候我们啊，我们现在有现在比较开心，比学校还好，对我们不开心。慢慢再来调整，再快一点。好，没事，我们大讲大讲。天天坐在办公室里专门多讲一下生意，有做起来就很愉快。我这东西专门就是做的，专门就专门现在不专门就讲，不做的，没有，就我们天天就讲。还有，今天我的儿子说，哎，我这么大了，这孩子，那时候我看没有用，没有心理作用。他们说是听他的，我那边还可以，但他们是平时。why is it not showing? 就对，我把这个翻译上前叫过 PPT 的就是喝那个没有加奶的那个黑咖啡的话，就是正大点，必须比较危险。他那个他那说的是，然后喝那个黑咖啡。没有，主要是我现在我明白一些，我都不是好健康，喝多了觉得，当你喝成黑咖啡都没有味道的时候，证明就已经喝太多了，对面站在哪就是喝太多喝的已经没有感觉，对，就是不加奶，就喝的太多，你喝了喝了出来，我已经没有问题，但是我喝在黑咖啡，什么地方在海里吃，不一样。不辛苦。会太快了。对，刚才说快，刚才说的慢，快是调整一下大家的使用价吧。 我上课，就学校规定是有这个片基本上都这样，现在考试也是，但是因为有学生可能买点多一点，主要我是用的，不管多大家上课就是很多问题可以看。我做这些是没有的，我之前看的。啊，我就没有，我没有这个，我一般都是可以的，有一些重要，但是有一天太贵，所以直接让我调一些，不好意思。今天回不来呀？很难哎，连我对他会的时候，必须有他对这边现在真的赢了，他现在没有情绪化，在上面，我拍那个他们会上还有时间，没办法。方便，我去参观一下，你看一下。对实际沟通的，非常。我现在已经跟没有什么东西了，多几还有。拿一个大学学生比例导线。对啊，可能你的学费的没有级别，你们这课的费用刚刚我找线上和线下。
So someone remind me that next Wednesday is Mid Autumn Festival second day. Okay, so we don't have class. Just to remind you, because we are 13-week semester, so we only have 12 weeks to teach. So it's okay. We don't need to make up that class. But yeah, 12. And the only thing is probably you may know already is like in the middle of October, I will go to conference in Macau. So I not gambling, okay. And then I will have to make up that class on Saturday. So I'm sorry about that. But of course, all the class is Zoom. So in case you just can't do it, you can do the Zoom or you can attend by Zoom. That particular class, you can attend by Zoom. I mean, we don't need to have approval from me for that particular makeup class. Okay. Of course, if you don't really want to do it, you can do you can appear in the Zoom as well. But anyway, I hope that you understand this can give you the standard measure, right? Remember why you want to do mean variance is the number that describe the data. And usually this is a report to the people, right? And although we have used the standard package, I want to introduce this package to you. It's called the SCIPY. This package is a lot of scientific computation package. And later you will see some machine learning or regression, we will use this package again. So we'll use this package, in particular, use the stats sub-package, sub-library of this SCIPY, okay? So what we do is, from this, I import the stat as a ST, because they have this library have many sub-library, okay? And use here, I also use the NumPy library, which also have many things. They have the mean, median, they don't have mode, but they have max, percentile, variance, SD, right? But mode still rely on the stat package, okay? I don't think I need to run all this thing, but I guess one thing I want to explain a little bit is this DDOF, which is something we out of all the rest. This DDOF is degree of freedom, which means that 1 means n-1. Okay, sometimes you want to adjust n-2, but for the variance, it's just 1. So it's just DDOF equal to 1. It's no, you don't need to change anything. This is the standard I already put in there. Okay, so I don't think I need, anyway, I just copy and paste in case some of you really want me to copy and paste. But I just copy the first line because that will be sufficient. Okay. And why I have NP array? Because if I want to use the numpy package, then instead of the standard thing, I use the NP array to make sure that it's compatible with the function I want to use. Okay. But you don't need to worry about that, because if you use the Panda package to import the data, already all the NP array is compatible. So you don't need to really worry about that. But I illustrate example that's why we have that. Okay. So what I meant is, if you remember, we have NP with the price, right? Price data, right? The price is coming from the hotel thing, right? So if I do that, it will be fine. Okay, you don't complain. So because remember, the price is come from the CSV file is the panda doc CSV underscore CSV, right? And then we pick out one column there, right? And that column, we pick up the price, right? You can immediately count the price, right? So you don't have to declare NP array, because once pass through the panda, everything works miraculously. Okay. Now this is people said one picture worth 1,000 work, so that's why you want to have a blog spot or the volume plot to show the median, the range, interquartile range, right? And these are the thing that want people to see. Okay. So what they're doing, again, go back to the hotel data, right? And here they have the other data set is Europe underscore price, which have data for Vienna and also London. So they want to compare different city. So the data is a little bit more complicated. Okay. And they focus on, as we see, 3 to 4 star hotel, not very expensive hotel, below $1,000. Okay. What they are going to do is to compare these two data using the histogram. Okay. Do you note that these two histograms, they focus on relative frequency? Why? Ask yourself, 10 seconds. If you remember why I talk about absolute and relative, absolute is good for its own self. Relative is easier to compare different data sets. The reason being that Vienna only have 200 data points, London have 400. So if you do absolute, that's not very easy to see. But when you relative, you scale it, then you can easily compare, right? London is more flat, and Vienna is more centered in this one, right? Only you can see this from the relative. If you're absolute, then it's a little bit misleading because it can be as tall as that one. Question? It's okay to stretch, but no problem. And also it's important to stretch. So here is the data, okay? So I have two data set here. The first data set is the prices of the hotel, and there's some features of hotel, okay? So just download it. I think from now, I think there's nothing, everything should be very simple already. You have seen many times, so I'm not going to explain this line by line. In case you still have issue, please ask me, but I just leave 10 seconds for you to copy and paste in case you want to do it. But it just URL and use the Panda to read the CSV. Okay, I hope at this point we have repeat more than 10 times, then you should be comfortable with that. Don't feel too stranger. Right. So that's a two data set there. Okay. Now here you will see, maybe you can look at the data first, because we want to merge the data set, then it's good to take a look at what the data is. Okay. Now let's do this is by looking at the price dot head, have some guess of some feeling of what the data looks like. Okay. This data is the hotel ID, right? The price, right? And whether there's offer there, time, date, holiday, and those kind of thing, right? These are the hotel price data. And look at the feature data. Feature head. Okay. Actually, this is the data without price. Looking at particular hotel, what are the characteristics of hotel? Okay, let me repeat what we're doing with the data set. One is telling us the date, hotel, at what date, what price. Multiple, one single hotel, right? Okay. One single hotel can have multiple different prices, right? Hotel ID, right? Different day, different prices. Depend on the room, how many feature, right? The price data. And this, right, is hotel ID 1, 2, 3, 4, 5. So each hotel, right? All the feature there. Okay. What we want is to combine these two together. Okay, and do some analysis, right? So you can see this is a many-to-one matching or one-to-many, depending on how you look at it. But you can see it's not one-to-one. Unlike the first one, we just do the join and we're done, right? So it's a little bit more complicated. So we need a little more complicated version of the merging. That is require a slightly advanced version we call Panda merge. Okay, I merge the data set called price and the feature. These are all two data sets. How I merge it? If what called left merge, right? Because price we have hotel ID, and the feature have ID there. So there's many things here. Left, right? So this is the price. It's a feature, right? You match the feature. There's a one-to-many, right? Left hand side. Okay. So because as price is the idea is because price has many one, right? This will map to many of them. So it's left merge. If otherwise, use right merge. So if you swap these two, you have to use right. But this is the way I merge. Is that clear? So left means you try to, this is the origin, you just try to map that. Let's run it, then you will see what it is, okay? Then you see how it looks like, okay? And based on what? Based on the hotel ID. Okay, let's look at it, then you will have some idea how it looks like, okay? Hope that you are more comfortable with that. So we learn how to merge, except join is here. So we have hotel ID. This is the thing, but I I'm merging this data to each one. So the first one is hotel ID one. So every row is the same, but I merged there. Is that clear what I'm doing? Take a moment to understand what's going on there. Okay, because the first few rows of the prices are the same hotel, right? But I want to feature on each column there, so I just use the left merge because this is a many to one matching, right? If one to many, then you will be using the right. Okay, but is that clear what we're doing here? Is that okay? So you learn how to combine database by using the Panda package merge to combine together. Is that okay? Okay. And the next thing you see, I delete the price and the feature because I no longer need them because this is the final one I need. I want to take it out from my data, from my memory. Okay, it's always good to take away things from a memory because Python is not very memory efficient, especially when large data set. So always once no longer needed, delete. Remember, just delete from the database, right? You can always load it from the CSV file. So it's not going to harm your data. Okay. So you just delete them. This part is not very essential. You can do it, you can skip it, don't worry. But once you did that, the price and the feature no longer appear here. It disappear from the data. Okay. So there's no longer you can no longer see price and feature here. Okay. Why we don't need that? Because we already have something we need. Is the hotel, is the whole data set. Okay, we combine the two. Is that clear what we're doing? So we have two tables. We merge together through the pd.merge. Okay. And why we can't use join? Because it's not that simple. We can just join because your two table is exactly the same ID, same one-to-one match. This we can just match and done. But now we have to specify how we merge. And the price has many ID of similar one, right? And then I want each row would copy the same thing here. So I would do the left merge. Okay. But I think this is the most useful thing. This left merge is the most, you can use the right merge, but I mean, that's the same thing, right? Usually you use the left merge, it's done, right? Because you can just swap everything's left, right? Okay. And this, the ID is based on what is being matched. Okay. And here, one thing is they got ID is they give it to you. Usually you have to generate it by yourself, right? Because no one gives you this, right? But we don't talk about that. But you have, when you actually work on data, you have to generate this hotel ID by yourself. Okay. Now, once you do that, then we do the crazy filter here. Okay. Let's read one by one to understand what's going on here. Then you see what we're doing. This is very important to filter out the data, right? The first line, I only keep the data the same in a particular day, right? So I put the year to the 2017. Month is, the first month is not weekend because we're supposed to go to weekday. Okay, up to you what to filter, but he focus on the weekday because he's going to a business trip, so weekday. And I want to focus on the city which belongs to either in this or this. Okay, or you can say equal to this or this, but we don't talk about or. So basically, just the city is either this or this. Okay, it's in, so it's either London or Vienna. Okay, and the next is focus on hotel, focus on 3 and 4 star, focus on the case where no star is gone. When there's no star, focus on this city actual. There's some, you look at the book, they tell you city actual is the way that they the city is not actually correct because it's a greater area, greater London, greater Vienna, right? Because Shanghai is a small area. The greater Shanghai is a very big area. right? Probably you know it, right? 大上海, right? Shanghai 是大上海 was bigger. So the price is 600. So this is the way. Okay. So that means you filter the data. Now, what you do it, once you do it, then you can look at the data is much smaller. So the hotel first, we can check how many data we have. Hotel, we have, almost like 115,000 data point. Okay. Now we cut it. Then let's see how many data we left. Okay. Now, once you run that, the hotel cut remains 600. Once you cut, right? Basically, once you cut this, you just drop to only 5% of the data set, right? Because you focus on only single day and so many things, then you cut like this. Okay. Now, these all steps of cleaning data should be in your program. You start from the raw data, and you can tell the people how you cut it at the end. That is the standard way to do analysis, especially you are IT manager, right? You should document very carefully how from the data to your result, right? Why? Because when you change the data, then you can do it again, right? You don't want to reproduce the wheel, right? That's what the programming do, right? Program means something you can repeat, right? Now, what here we do is, okay, I want to look at the Vienna price, and I look at the bean is $10. This is the Coke. I think after the Coke that we have done before the break, nothing is new here, right? I hope, right? This is, I look at the data, cut out this Vienna, look at the Vienna's price, I look at the bean, I draw the graph. Is that okay? I think once I do that, nothing comes out because the graph is on the next page. So I think this shouldn't be too difficult for you, because we have seen this for many times, the disco. Okay. Some of you may actually ask me why I always do this. This import, you don't need that, because once you import once, you don't have to do it every time. But I just keep it because you may run it in the middle of your code, so I just keep it. Okay, you don't have to do that. Okay, and you can see this is the Vienna's price. Okay, basically you have two tables, you combine and take out the column you need, you print that out, a table histogram, right? Is that okay? I hope by now you should be comfortable of downloading the data, combining data, clean up the data, draw a table. Okay, looks repetitive, but that's how we learn, right? We repeat, right? That's in the kindergarten, right? How you learn, just repeat many times. Okay, and right, because someone said, right, the summer Python class is too fast because time constraint, right? It's just 1 month. We have 3 months to repeat ourselves many times, so we should be able to learn this Python. You feel comfortable, right? Maybe now you don't very comfortable to say you know Python very well, but after 3 months of this kind of training, then you should be able to comfortable, at least in terms of statistics. Okay, not programming, but at least use the Python as a data analyst tool. You should be very happy to comfortable to tell people you're okay, right? And no people will think you can't program because you're from ITM master, right? So no problem. Now here, the next one is London price. There's nothing new there, but just cut out London and draw a diagram, right? So I know it's very boring. Some people are yarning, but as I said, we always make sure that no one left behind. So I just do that. Because as a student, I always hate people. I always don't like the class where teachers say it's very easy, go home, do it yourself. So I try to list every single step very detailed. Whether I cover it or not, but I just put everything in great detail, right? Especially I have a math class, the math teacher, hey, it's very simple. Okay, do it, go home and do it. And I really go home, I'm not going to do it anyway, right? So that's why I just show it to you. This is the hotel price of the London. So I try to as transparent as possible. I mean, what we call it, leave no stone unturned, right? Just turn every stone. Is that okay? The next is beside histogram, you can draw a density plot, which will be very similar anyway. Okay. And you can plot them together in a line because you just connect all the top point in histogram, right? And that can make comparison easily. You can see, right? That's what they said, right? The density plot looks nicer when you compare. Okay. And also you can compare using a table. Okay. I think by now, with your Python skill, you can do it by yourself. How to create this too. Shouldn't be difficult. You just group them and do the aggregation. Okay. Calculate all this and put it in table form. Based on what you learn in the summer in the Python, you'll be able to create this table. I'm not going to do, sorry, I leave this exercise for you. But anyway, you don't really need it anyway. So I just put it there. What remains is we're a little bit behind the schedule, but I mean, should be fine. So besides this, this part I will go quickly because I don't think this is super important. It's when I teach undergrad, I teach a lot of this, but for the master level, I just fastly go over and just because it's not very important anyway. For IT manager, so these are in theory how the distribution looks like. The common distribution because they fit a lot of application from scientific phenomenon. Okay, but when you apply to business or human behavior, this may not fit very well. Okay, but they are the common distribution. And why this ideal is good because the distribution can be reduced by a single parameter or several parameters can describe the whole thing. And the good thing about this is if you know how to estimate these parameters, then you can do a lot of prediction, right? Because this model basically tells us what, okay? We learn a lot of distribution. We draw a lot of graph, right? Like this, right? We draw this graph, right? It's very complicated, right? But if we're able to summarize this by so-called some mathematical model or probability model, then our life is easier, right? This is type what, this type what, okay? Any people like astrology? Okay, 星座, right? 双鱼座, all right? This kind of stuff, right? Some people will think people are very different, right? And then you can divide them into 12 types, then make our life easy, right? Okay, you belong to this type, you belong to this type, so on and so forth, make easier. Same, right? This distribution belong to this type, okay? As long as you figure out, okay, you belong to the type of this particular type, then you can say, okay, this is my type, this is not my type, right? So that's the same idea here, right? So if a distribution, then we can fit the data much easier, okay? Say, what do we want to say? Say, for example, look at the income. The data look like this. Doesn't look very nice, okay? But you take a log, okay? This looks like a bell, okay? So that's normal. So that's why this is called log normal distribution, because after log become normal, okay? So that thing look nice because normal, we know the shape, the bell, right? 正态分布, right? That is we know, right? So many things looks like the Paretian model, right? So why do we have to do about all this crazy thing? Okay, let's quickly finish this guy. Not very important. Okay, I do it because the book had that. Some probability, I mean 概率. So to talk about all this is I don't think we need a probability class because you learned this in the college, right? But I don't want to go into detail here. Okay, but what I want to show you is there is a non distribution, 伯努力分布, so something like that, right? And looks like the 2 point there is the shape. You can fit the data, okay, or a binomial, right? And they look like this, more like bell curve, right? And the uniform there, normal is the most common one. Okay, this is something worth talking about a little bit. It's a bell curve, and probably you learn the central limit theorem, 中央极限定理, that give you the almost everything give you the normal. That's the central theorem of the statistics, right? This is the most important theorem in statistics. Is if you have things that come out of a random process, I mean, basically, most likely the thing that come up with decided from some small sub-processes, which is also random, give you a normal. Okay, so basically is if something is determined by nature, by randomness, right? Like the height, your weight, right? Your height is determined by your gene, what you eat, what your father eat, what your mother eat, right? What your grandfather eat, so and so forth, go on, whether exercise, so and so forth, whether when you're born, whether the sun is on this side or on that side, where the location of Mars, so and so forth, many things happen, right? That determine your height, your IQ, everything, that belong the bell. Bell is the normal, right? And the normal will be characterized by the mean and the standard deviation, just two number, right? Two number can tell us all the normal, right? So that's why it's very convenient, right? And we use it all the time, right? And income is not normal, but when you log it, it's normal. Okay, why? Because you can imagine your wage increment is more or less more or less random, right? Everyone's income may be very similar, but your income increment, right? How much income rises every year may be a random thing. So that thing end up to be a nicely normal. Okay. And there's a not normal, as I said. Okay. And there's Pareto. I don't want to go over that because there's nothing terribly important. And then we are not really using it except normal. And I think everyone knows normal. Am I right? 正态分布, I think it's okay, right? I think that's okay, right? The bell curve. I mean, if you have question, you can ask me, but once we talk about this, you will know it, okay? But I just keep everything here to be considered the book, so that, I mean, you can come back to it, because we are not using the rest for the rest of the semester while I talk about those, and unless you become statistician, right? You're not. So I mean, that's okay. We just being lazy, I just skip, right? Because we spend more time on Python, so we have to cut something out. If you, as I said, if you really want to know this, you're welcome to attend my undergraduate class, which or there's a video record there. You can look at those. I mean, there are lecture notes talking about all these things. In undergraduate, I taught this for 2 weeks. I mean, 3 weeks. I mean, what's probability? What's random variable? What about the distribution? I mean, so on and so forth. Maybe 3 to 4 weeks to go everything in detail. But I mean, we don't have the luxury of going that in every detail. Okay. So the graph and table are the way that you would want to show. We know the graph already. And then, of course, table is also very important. Okay. Since you use Python, general table is very easy. Just click and come out. So it's always something that we will do when you run regression to a table, right? When you run machine learning models that some of them are table, some of them you don't, right? For example, regression tree, you can't really have table because just come out, or some ensemble method, some complicated method that just come out with solution, right? In those cases, you still need to draw some graph and table to show how your mechanism works, okay? And here is something that you should read them when you try to draw a table, because of how to have a good graph and good table. There as a business presentation, they will be very careful, right? Because we often do a terrible job of drawing a graph or making a table, okay? Especially for college education in China, which don't emphasize on this. I mean, maybe you're B school, that's okay, but if you're outside B school, even in Hong Kong, everywhere in the world, is presentation not something you teach. It's taught in the college level, or even in the high school level is not taught. So everyone do a very terrible job, including me, myself. I mean, when I go to college, I do a terrible project, do a terrible graph, do a terrible table, right? But as a B school, I mean, I think the 3-year college I have here is learn how to present and learn how to draw a good table and do graph. I mean, although very expensive lesson, but that's what I learned. I mean, the most useful thing, okay? And since this course is joined with the B school, I hope that you would be able to draw a good graph and good table. That is very important because, well, we're in a business sector, right? You're the manager, right? Manager have to be able to communicate to your boss and your client and your staff, and most likely they don't have time to look at every single detail, right? Good table will help them to save time to grab the key part, right? Same as the good table as well, okay? I don't have time to go to detail if you want to look at the book, but this highlight this because of time. We can't really go over that. But one thing that I want to emphasize is in your report, your table graph is people try to stuck as much as material as you want. That is the worst mistake you would ever make for a business report. Simple is the best, right? Because the principle is called KISS, KISS, is keep it simple, stupid is the best. And the other principle you should follow is what we call the bottom line first, okay? It's not writing in the way usually the Chinese people write, different from Western people, is we write things in a very confident way, okay? When you write a story, you write something happened, here, at the end, okay, oh, I understand, this is the story. But when you're in the business, you don't do it. You tell us exactly what you want to tell the audience. You should buy this product. Here's the reason. It's not saying, here's the reason I want to buy this product. No, just reverse it. Okay, I want you to take this action. I want to buy this and explain. Okay, so this is how I expect you write your report. How you do your presentation is do this, and your report should not try to cram as many things as you do. You need to learn how to cut. Okay, just imagine when you dress yourself, come to school, right? You don't go to your jewelry box to pick up everything, put on your head, put on your face, right? You put something that match together, not very nice, right? Just like your drink, right? You like coffee, you like tea, you like soup, you like Coke. You don't put everything in the same cup and drink, then you drink terrible, right? Same. So don't put everything there. Just put the thing enough to convince people. I think that's most important when you write your report. I mean, there's something. That's why I teach this in the B school, right? Not stat department teach this one, because we want you to be the IT manager. You want to present the report in the right way, in the managerial way, right? Business professional way. So I hope when you present, the same. Okay, so sorry, overrun for 3 minutes, but hope you catch the bus. Okay, I will see you after the mooncake. Okay, and don't eat too much. I mean, otherwise, stomach too much oil. I see you the week after.